Welcome everyone to our Solar Photovoltaic Fundamental Technology and Application course. I am sure you must be excited to go through our classes. Today we have our first week and our first module. In today's lecture, we will give you a basic introduction about why this course is important about, or what is all about the energy, and what are the different sources of energy and how we harness this energy, and then we will make a case why we have to study about the solar photovoltaics. Now, energy matters. So, you know that if somebody becomes very weak, then we say that he don't have a lot of energy, and then we give some external source of energy to make him or her work. So, just like a human body, similarly, if you look a broader perspective like our civilization, so from the morning to the night, to the time we go to the bed, we can't imagine a single moment of our life without having the energy or some forms of energy. Maybe it's an electricity, or it's like a thermal energy, or some other kind of energy, but it will be some form of energy. Now, whether you are using your electronic gadgets, or whether you are watching this video in the computer, or you are watching some television show, or you are using your mobile phone, and each and everything, starting from the even you take an example for the car fuels and everything, and industry, academia, everywhere you see that we can't consider a single moment without having the energy. That's why the energy is called the blood of the civilization. Now, also recently there was a survey worldwide to recognize what are the top few problems of the upcoming world. And if we have to identify the 10 very upcoming problem for the next few decades, then it was considered that energy tops all the problem, because all other problem like economic problem or residence or health and all these things directly or indirectly is related to the energy. So, that is why it is a quest for human being for quite a long time how we can generate this energy. Now, so usually like there are different forms of energy generation. So, one of the major form which we use the energy in our day to day life is in the form of electricity. Now, this electricity is generated usually by burning fossil fuels like coal and petroleum, natural gas, etc. But as you know that as the population is increasing, so the effective space used by the people and the effective number of gadgets which is utilized by the people is also increasing day by day. But the resources of this conventional sources of energy, they are limited. So, very soon they will be depleted, and very soon we will be out of any source of energy. So, that is one of the reason, like we have to be very concerned about to find out an alternative source of energy. And apart from that, whenever we use any form of energy, let us say we are burning coal to generate some kind of thermal energy. So, in this process we generate lot of waste or carbon residues. Now, this waste or carbon residues is actually add pollution to the environment. They are not good for our marine lives, they are not good even for lot of plants and animal lives also. In addition to the fact, like all of us probably aware of this term called global warming. So, if the increasing number of energy utilizations always increase to the more and more global warming, a phenomena which refers to the increase of the temperature of the earth's surface, and the long time consequence is the change of the weather of the earth. And as you can see that all the seasons like summer and winter, they have been altered, and the temperature variation has been changed also significantly, and scientists say that this is all because of global warming. Now, these all things are related to how effectively we utilize and manage the energy, and all these things direct us to find out a safe use and a non-alternative environmental friendly source of use of some form of energy. And that is so buzz about this field, and that is why there are so much of academic and industrial research interest in this field to find out an alternative source of energy which will add less pollution to the environment, but at the same time which will be able to fulfill the demand of our day to day life, and also it will minimize the global warming. So, if that kind of questions we need to answer, so then we have to do more and more research about finding what are the some alternative source of energy which will be less pollution free, or which will be more environmental friendly to that sense. So, that is why we are looking towards something like solar energy, something like hydropower energy, or wind power energy. Now, there are different forms of this renewable energy. Now, so as a tropical country like India, in most of these places get a lot of sunshine, and it is sure that for us and future few generations, for all of us, like sun will be there. And if by some way, like if we can harness energy from the sun, so that will be kind of environmental friendly, because all of us have seen that plants make their food by using sunlight. They utilize the water molecule and they take the carbon dioxide from the environment, and by using the sunlight, the chlorophyll, the green pigments in the leaves. So, by the process called photosynthesis, they make the glucose molecule, oxygens, and basically they make the energy molecule. So, we have learned that lesson. So, inspired by this idea, people were thinking, okay, can we mimic the same kind of concept in the lab? Can we make an artificial photosynthetic system in the lab? So, that was the inspiration behind utilizations of the solar light or sunlight for making some useful form of energy, and that leads to this photovoltaics technology or solar energy technology. And since, as I said, that a lot parts of the India, like both the coastal area as well as the plain area, we got a lot of sunshine like during most of the time of the year. So, if we can utilize this sunlight to make some useful form of energy, that will be more economical, and also that will be environmental friendly for all of us. And this is not only the picture for India, when we can say that is for rest of the world, this idea is also valid. Now, there are some places where people use the hydral power or the flow of the water to rotate the turbine and use that to generate some form of energy. Now, in some area like especially near the ocean or near the coastal area, you can say that the wind is very nice. So, we can utilize this wind power to generate some form of electricity. So, there you can see some windmill is there. So, these are all different source of energy, but out of all of that solar energy is especially very popular for number of reasons that we will discuss in our course, and it is taking an exponential space both academically and industrially nowadays for applications in our domestic life as well as for different industries, airports, vehicles, cars, and everywhere. So, in our course we will learn in details about the different form of this technology, how to generate the electricity from the sunlight, what are the underlying basic technology behind it, the basic physics behind it, and then we will also go to some engineering aspect, like we will discuss about the different generations of the solar cell. For example, we will talk about the silicon solar cell. The solar cell which you have seen in your calculator. You must have seen that in your calculator there is a small transparent panel embedded in the right hand side. Some calculator have, some calculator does not have. So, basically that is a solar panel, right. So, and in many of the house also we have seen that this solar panel has been installed. Now, these solar panels, they are amorphous silicon solar. So, we will also learn how to make this kind of solar cells and what is the mechanism they generate the electricity. And coming to the modern time, so as the technology becomes more and more matured, so the silicon technology has also evolved over the time, and people have came across with some new form of materials. Now, this new form of the materials, they involve some organic materials as well as some engineered carbon nanomaterials. Now, all of this thing has led to some new kind of solar cell. They are called third generation solar cell, which we will discuss in our course. Now, and finally, we will see that both in India and all of the countries, the solar energy or the solar cells has now utilized not only in the space mission, but for everywhere. So, what are the technology and what are the technological success behind that story, that we will discuss in details in this course. But before going to all of this thing, like first we have to have our like basic idea, like where we are starting from, or where basically where the problem starts from. The problem starts from our conventional source of energy. So let's look at the first, like what are the conventional source of energy, or how we get that things, right? So as we said that energy is the power derived from the utilization of physical or chemical resources, especially to provide light and heat or to work. So whatever we do, either finally we have to generate light, or we have to generate heat, or we have to do some kind of work. So that is our ultimate goal when we generate the energy. Now the energy is the quantitative property that must be transferred to an object in order to perform work on or to heat the object. The SI unit of energy is joule, which is the energy transferred to an object by the work of moving it a distance of 1 meter against a force of 1 Newton. So if you apply a force of 1 Newton, and if you want to move an object a 1 meter, so the amount of work done, that is called the 1 joule, and that is a conventional SI unit of the energy. Now as we just mentioned, the sources of the energy, they can be broadly classified into two different categories, namely the conventional source and non-conventional source. So what are the conventional source? So as we have mentioned here, by conventional source, the one of the main example is that coal, right, and then this oil and natural gas. So these two things, coal, oil and natural gas, I mean you can say that they are the heart of producing energy nowadays. Okay, so we burn coal, we burn oil or natural gas to drive our car, or like generate electricity in our house. In addition to that, there are civilian application of the nuclear power. There are a lot of nuclear power plant in the country which is used to generate the electricity. And then there are other source of conventional source, like let us say from a forest you can get lot of woods, and in the village side if you go, that we will have seen that we burn the wood and we can generate thermal energy, that is also a source of energy. And then the straw, an agricultural byproduct, and then the cow dung or the biomass, right. So these are like some conventional source of energy. And by non-conventional source of energy, we mean like some of the popular example are will be like wind energy, bioenergy, and then tidal energy, geothermal energy, and finally solar energy. Now wind energy, that use like the wind power to rotate any turbine to generate the electricity. Bioenergy, like they use some bioactive bacteria to convert some kind of waste material to generate the electricity. Tidal energy, so that there we have used that like the tidal or the water flow, the power that has been converted to the electricity. Geothermal energy, like it is considered that in the earth's surface there are some amount of heat gradient, and if we can extract that the heat gradient, that will also be useful for us. And then our solar energy, which we will discuss in our course. Now the conventional source of energy, now conventional source of energy are also called non-renewable sources. Why non-renewable? Because like renewable means something which we can generate again and again. So non-renewable means which we cannot generate again and again. So this coal, natural gas or petroleum, they are actually extracted from the earth's surface, alright. So I mean their resources are limited, they have been formed long back in the Carboniferous age. So once they are formed, we are using that sources. So we cannot renew them. Today if you want, like we cannot make a source of coal. So we have to use what we have. That is why they are called non-renewable sources. Now these sources of energy are in limited quantity except hydroelectric power. These are also divided into commercial and non-commercial source of energy. Now what are the commercial source of energy? Commercial source are those for which consumer has to pay the price to purchase them. Like for like in our home we know that we have to pay the electricity bill, and why we are paying the electricity bill? Because like the electricity which we are getting in our home, that has been generated by burning coal or by like some kind of oil or natural gas, usually by coal. Now all this process involves some kind of money. So this is a form of revenue generation. So that, and we have to purchase this electricity from the government or some like private organization. So that is why they are commercial source of energy. Like some example of this source are coal, oil, natural gas and electricity. On the other hand, agricultural waste like straw and dried cow dung, they are used as a non-commercial source of energy. Well, I mean, in some of the parts of the world, like even people have to pay to get an energy which have been derived from the cow dung. But as far as our country is concerned, if you talk about the raw material like straw, which is an agricultural byproduct, right, or the cow dung, dried cow dung, that is available freely, and we do not need to pay any money for buying straw or cow dung or to generate the electricity out of that. Now, coming to the conventional source of energy, coal. So, coal is one of the major source of energy. India is now the second largest coal producing country in the world. Coal was formed around 255 to 350 million years ago during the Carboniferous age in hot damp regions of the earth. So, we are talking about a time which is 255 to 350 million years ago, long back, during the Carboniferous age in the hot damp regions of the earth. In the next slide, we will show you a schematic diagram to get an idea about this phenomena. Now, what happens, the plants and animals that occurred during this period along the banks of rivers and swamps got buried alive or after their death into the soil, and due to the heat accompanied by the pressure gradually got converted into peat and coal over a millions of years of the period. So, basically what happens, like whatever the animals and the plants which were there across the river side, they got buried either on a living condition or after the death, and then over the time by the use of the temperature and the pressure and also in the presence of some anaerobic bacteria, they have slowly converted to the peat and coal, and this has taken a long period of the time. The coal is mainly of three types: anthracite or hard coal, bituminous or soft coal, and lignite or brown coal. So, in this picture, like we are showing how this coal formation is happened. As you can see that here there are these plants are there, and these are some of the animals who have been buried in the earth's surface, and this is a time axis. So, over the time, by the use of the heat and the pressure, so these are a lot of this plants and animals, they have been slowly converted to the different forms of the coal. First they have converted to the peat, and then the lignite, and then the coal. So, so from the peat, when the pressure is there, you will get the lignite, and then if you use heat also along with the pressure, you get a subbituminous, and over the time it become more solidified to become bituminous and anthracite. These are the different form of the coal. Now, so basically if we increase the heat and the carbon content, based on that these different classifications of the coals are there. For example, peat. Peat is actually not a coal. It is partially decayed plant matter in swamps and bogs, low heat content. So, I mean whenever the plants and the animals they got buried, so they have been partially decayed by anaerobic bacteria, right. So, these are these are called peat, they are not coal, and if you burn them, they are the amount of heat they will generate is not that high. Okay. Now, if we allow the heat and pressure to act on the peat, then they convert it to the brown coal. Brown coal is called lignite. Okay. So, low heat content, and they have a low sulfur content and limited supplies in most of the area. Now, if I apply more heat and more pressure on the lignite or the brown coal, so it will convert it to the soft coal. The soft coal is called bituminous. This is extensively used as a fuel because of its high heat content and large supply, normally has a high sulfur content. So, we can see that the sulfur content is related to the amount of heat generation. For lignite, we have low sulfur content and the amount of heat generation is also low. For bituminous, the sulfur content is higher and the heat generation is also higher. Now, starting from the soft coal, if I put more heat and more pressure, then we get a hard coal or anthracite. Okay. So, anthracite is highly desirable fuel because of its high heat content and low sulfur content. Supplies are limited in most of the area. So, there are three different types of coal we have discussed. One is the brown coal or lignite, another is the soft coal or bituminous, another is the hard coal or anthracite. Now, how we get from one of them? By applying gradual heat and pressure. What is the major difference between the lignite, bituminous and anthracite? The amount of the heat generation from them. Now, the second conventional source of energy is the oil. Oil is considered as one of the most important source of energy in India and also in the world. It is widely used in automobiles, trains, planes and ships, etc. Crude oil or petroleum, the lifeline of global economy, is contended mainly in 11 countries forming the OPEC or Organization of the Petroleum Exporting Countries. About 70% of the global petroleum reserves occur in these countries. So, these OPEC countries or the Organization of the Petroleum Exporting Countries, so 70% of the global petroleum reserves occur in these countries. In India, crude oil was first recovered from Makum in northeast Assam. Later, drilling for crude oil was done at Digboi, at Dibrugarh, and then Narkhatia and Surma Valley, also situated in the northeast. The oil field also lies around Bay of Cambay, Gujarat. The most important achievement was the exploration of the oil in Bombay High on the conventional or the continental shelf of Maharashtra, located at a distance of 160 km northwest of Mumbai. These are some of the places where India have the oil refinery. Although these are some of the example, India has also some other place from where the oil has been extracted, and a continuous search is going on to find out the new place for the oil reserve. Now again, the oil formation follows the same story like a coal. You see, this is the ocean and there are the marine organisms are there. We are talking about a story which is 300 to 400 million years ago, long back. So what happens, these marine organisms, they got buried, and then from 50 to 100 million years ago, the sediment and rock, and we have a layer of the hard rock and the porous sedimentary rock, and the organisms which are like which is situated in this hard rock and the porous sedimentary rock, in this area the animal and the plants has been buried away. So the organisms turns into oil and gas over time. And finally, at the present time they have been converted to the trapped oil and also some trapped gas, and this is the oil and the gas that we extract using a tube. So, the natural gas also produced in the same way, right. So, conventional source of energy, the third source is natural gas, has been the most important source of energy since the last 2 decades, and it is worthwhile to mention that in western countries there are more and more interest to use natural gas over the oil. In India it has also been started, and you can see that the cost of the natural gas is little bit lower than the oil like petrol and diesel. Now it can be produced in 2 different ways, with petroleum products as associated gas or free gas obtained from the gas fields. So whenever we extract the petroleum as a byproduct, also we can get a natural gas, or there are some places in the earth where the natural gas is buried like as a gas field and we can extract also from there. Now this coal, oil and natural gas, these 3 things mainly, they are all the examples of the fossil fuels. So what is a fossil fuel? A fossil fuel is a fuel formed by the natural process such as anaerobic decompositions of the buried dead organisms containing energy originating in ancient photosynthesis. So all of these animals and plants, when they got buried in these swamps and the river banks over millions of years of the time, by using the pressure and heat and by anaerobic degradation, so they have been slowly converted to coal, oil and natural gas, the different source of the conventional energy. So these are called fossil fuels. Now another conventional source of energy is the nuclear energy. Nuclear energy can be generated by both nuclear fission and nuclear fusion, right. In one of the case, what happens, like one atom disintegrates into its constituent atoms, and when it disintegrates, so then what will happen, whatever the energy difference is generated, that is utilized. And in fusion, like let us say I have like 4 hydrogen atom, or like I wanted to combine this 4 hydrogen atom. So if I have like some constituent atoms, and if we combine them, so whatever the final atoms will get, there will be a mass difference of the final atom from the constituent atoms, and that mass difference is converted to the energy. That is a huge amount of energy we get, that is called nuclear fusion. Now either this fission or the fusion, it is very difficult to control these processes. Okay. In nuclear fission, nucleus of certain isotopes with large mass number is splitted into lighter nuclei or bombardment of neutrons in order to release a huge amount of energy through a chain reaction. And in nuclear fusion, two isotopes of light elements are formed to form a heavier nucleus, releasing enormous energy in the process. The heat energy produced as a result of either of these processes is used to produce steam, which runs electric turbine and generate electricity. Here there is a conventional nuclear power plant is showing. As you can see that this is a nuclear reactor and which have been kept with a very good insulator. The insulator is actually protect it from all kind of environmental leakage. Okay. So, the heat which have been generated from the nuclear fission that helps to heat the water, and that water, like that generate the steam, and that steam rotate the turbine, and using a generator we use the electricity. That is the safe use of the nuclear power. Now, finally, like the electricity. So, how do we generate electricity? Electricity is the common and popular source of energy. It is used in commercial and domestic purpose. Now, there are three main sources of power generation. One is thermal power, another is the hydroelectric power, and another is the nuclear power. Thermal power is generated in India at various power stations with the help of coal and oil. It has been a major source of electric power. In 2004 to 5, its share in total installed capacity was 70%. So, still we depend on the thermal power the most. In the hilly area of some parts of the country, we have the hydro power plant or hydroelectric power plant, and some part of the country we have a very small source of nuclear power plant, but the dominating source of energy or the major source of energy in the country is still the thermal power plant. Hydropower is produced by constructing dams over overflowing rivers. For example, Bhagra Nangal project, Damodar Valley project and Hirakud project. These are some of the very famous example of the country where the hydropower based dam has been made. Nuclear power is also a way to produce electricity. Nuclear power plants use uranium as fuel. This fuel is cheaper than coal. This is very interesting, right? India has nuclear power plants at Tarapur, Kota, Rajasthan, Kalapakkam, Chennai and Naraura at UP. Its supply accounts for only 3% of the total installed capacity. So, although uranium, as I said, that as a source of the fuel it might be cheaper than the coal, but the processing, when you talk about the total technology, it becomes very expensive. So, that is why the major contribution to the total electricity generation from the nuclear power is still very less. We have learnt about conventional and non-conventional source of energy. Now, just few minutes back we discussed about the renewable sources. So, we can also classify the energy about renewable and non-renewable sources of energy, alright. So, what is renewable source of energy? Renewable energy resources are mostly biomass based and are available in unlimited amount in nature. Since this can be renewed, that is regenerated in natural process over relatively short period of time. So, as the name suggests, renewable energy can be renewed over a short period of time. Renewable energy sources are inexhaustible, means they can be replaced after we use them and can produce energy again and again. So, we can do regeneration or recyclability. So, we can generate the energy from the same system again and again. So, for example, if I have a coal, once you burn the coal, so it generates the energy and then it becomes ash. So, we cannot use the ash for generating again the energy. But if I have a solar panel, today I can use them for making energy, okay, for generating energy, and tomorrow again I can use that solar power panel to generate the energy. I do not have to throw that solar panel after one time use to generate the again next cycle of the energy. Well, of course, everything has a lifetime. After certain period of time, it will lose its capacity that comes from the material degradation. That is a separate story. But in terms of the energy generation capacity or regenerability, this renewable energy sources will be those which we can regenerate it again and again over a short period of time. So, non-renewable energy resources are available in limited amount and develop over a longer period of time. Just we mentioned, right, coal, natural gas, oil, millions of years. As a result of unlimited use, they are likely to be exhausted in one day. These include various fossil fuels including petroleum products, coal and natural gas and nuclear energy. So, you see this in this pictorial diagram, we are classifying just to show you what are the renewable energy like biomass, like wave, and then solar power, water, geothermal, wind, and what are the non-renewable sources of energy like nuclear, then coal, oil and the natural gas. Both of them can generate the electricity. Both of them, the renewable energy and non-renewable energy, can be used to generate the electricity, but some of them can be used again and again over a short period of time, some of them can be not be regenerated again and again over a short period of time, and the making of their source takes millions of years of time. Now, there are certain environmental impacts of these fossil fuels. The main things are the following: the principal air pollutants resulting from fossil fuels combustion are the following: carbon monoxide, the oxide of the sulfur like sulfur dioxide and sulfur trioxide, sometimes represented as SOx, the oxide of nitrogen, nitrogen monoxide and nitrogen dioxide, you can also write as NOx, where X stands for 1 or 2, and particulate matters consisting primarily of very fine soot and ash particles. So, whenever these fossil fuels they burn, so they generate all kind of this pollutant gas like carbon monoxide, sulfur dioxide, nitrogen monoxide and some particulate matters. The burning of all carbon containing fuels inevitably produce huge quantities of carbon dioxide, and burning of these fossil fuels is estimated to contribute about 50% of the gas that are thought to be responsible for the greenhouse effect, global warming. So, only the burning of the fossil fuel contribute to the 50% of the gas that contribute to the greenhouse effect. Now, what we are doing to mitigate that effect? Who are the entity to absorb that carbon dioxide from the nature? Plants. But due to the growth of the civilization, we are cutting that plants. So, in one way we are burning the fossil fuels to fulfill the need of our day to day life, which is adding like 50% of the this dangerous gases or the greenhouse gases which is contributing to the global warming, and on the other hand the sources which can absorb those gases, that we are cutting. So, because of that this two-way work, so the total environment is getting polluted day by day, and that is why is a serious concern about the weather change and the global warming. So, the greenhouse effect, a term which you all heard about again and again in newspaper, TV, radio and everything, people talk about greenhouse effect. So, the greenhouse effect is very simple idea. So, here you can think about this is the earth's surface, right, and this is our atmosphere. So, as you know that this atmosphere has different layers, stratosphere, troposphere, ionosphere, ozonosphere, etc., etc. Now, whatever the radiation which is coming, they get absorbed in the atmosphere. Now, in the atmosphere there are also the air molecules are there, gas molecules is there. So, if because of the burning of the fossil fuel, if we add more and more this gaseous product, this dangerous gaseous product to our atmosphere, for example, if we increase the concentration of carbon dioxide, nitrogen based oxide and then methane, CFC, that is chlorofluorocarbon, a pollutant which is also released from the refrigerator, and then halon, ozone and then peroxyacetonitrate. So, these are all of these products they have generated by burning the fossil fuels. So, whenever we burn the fossil fuels, we generate them, and these are adding to our atmosphere. Now, what happens when the radiation falls on the earth's surface or on the atmosphere, this gas will absorb those radiations. So, what will they do? So, if they absorb the radiation, the job of the atmosphere was to transfer the radiation to the earth's surface, but they are now absorbing that heat here. So, they are the trapping heat. So, once they are trapping heat, so what will happen so basically the temperature in the top of the atmosphere is now increasing, okay. And on the other side whatever the radiation which is absorbed on the earth's surface, so they are supposed to reflect it from the earth's surface. Now, if I have a layer of this kind of highly dense, high reflective index gases on top of the earth's surface, then those reflected gas cannot escape from the earth's surface to go to the outer atmosphere. So, in one way you are blocking, you are increasing the heat of the exact nearest environmental atmosphere temperature, and in other way we are blocking the escape of this radiation after reflection from the earth's surface. So, what will be the result? Consequently, whatever the radiation which is not able to escape from there, they will go and they will get absorbed in this gas molecule and increase the heat of this thing. So, finally, the heat of the earth's surface is increasing. So, this effect is this effect is called the greenhouse effect. And as you can see this from this picture, it is directly related to the burning of the fossil fuel. As more and more like this high specific heat gases will add to the atmosphere, so more and more heat trapping and more like obstacle or the hindrance to the escape of this radiation from the earth's surface will occur, and that will effectively increase the temperature on the earth's surface and heat on the earth's surface. So that is called the global warming or the greenhouse effect. For an example, there is an estimate which have been done annual greenhouse gas emission by the different sectors. See, the industrial process, they add 16.8% to the greenhouse gas emission, power station 21.3%, waste disposal and treatment 3.4%, land use and biomass burning 10%, residual, commercial and other source 10.3%, fossil fuel retrieval, processing and distribution 11.3%, agricultural 12%, transportation 14%. So, what are the main sources? Power stations 21%, industrial process 16.8% and transportation 14%. Now, can we stop any of this process? Can we stop power station? Can we stop industrial process? Can we stop transportation? We can't stop any of this process. So, we have to run all these techniques. So, that means we will be continuously adding all these greenhouse gases to the environment. Now, you can see that the carbon dioxide consists 72% of the total greenhouse gases in the atmosphere, followed by the methane 18% and nitrous oxide 9%. So, these are very dangerous situations. So, to run our civilization, to run our day to day life, we have to run the powerhouse, we have to power station, we have to run the industry, we have to run the transportation. So, that means we have to burn the fossil fuels. One way their resources are limited, and other way when we are burning them, we are adding dangerous greenhouse gases like carbon dioxide, methane and nitrogen dioxide to the atmosphere. So, not only that, like I mean the immediate consequence we can feel and realize in our day to day life. They have severe environmental hazards, severe effects on the health. As you can see from this little boy, he is working in his house with a mask. You look at any of the metro city, like you will see even in the morning time there is a very dense fog or smog which have been smeared all over the area, and this is all coming because of the formation of the large particulate matter. Burning fossil fuels emits a number of the air pollutants that are harmful to both the environment and public health. Ozone, particulates and other compounds released during combustion of fossil fuels can be the reason for development of severe health problems including asthma, pneumonia, bronchitis, heart disease, neurological deficits and even cancer also. So, more and more this detrimental disease they are increasing because of this severe environmental pollution. The oxide of sulfur and nitrogen get dissolved in rainwater and form acids. This is known as acid rain. This water is very harmful to plants, animals and various monuments. So, you might have heard this story that Taj Mahal and other I mean this some historical monuments and the towers they are fading. They are fading up sometimes because of this acid rain, because all of this sulfur and nitrogen based oxide they can dissolve in the water and they can made some kind of acid, and if the acid then mixed with the water we will get the acid rain. So, they will corrode the surface slowly over the time and they will fade the color. There are two main methods of removing fossil fuels from the ground: mining and drilling. Mining is used to extract solid fossil fuels such as coal by digging, scrapping, and drilling methods help extract liquid or gaseous fossil fuels that can be forced to flow to the surface such as conventional oil and natural gas. A large amount of land is distributed and disturbed by the drilling wells, access roads, processing facilities and pipelines associated with oil and gas drilling operations. It can be severely harm wildlife population. When oil and natural gas are extracted, water that had been trapped in the geologic formation is brought to the surface. This produced water can carry with it naturally occurring dissolved solids, heavy metals, hydrocarbons and radioactive materials in concentrations that make it unusable for human consumption and difficult to dispose or safely. So, basically like the two major methods of extracting the fossil fuels, drilling and mining, they also associated with some secondary pollution. So, now we are convinced that we need a alternative source of energy. There are so much environmental hazards, there are so much hazards on our health. So, need for sustainable energy sources. the energy requirement of the world is ever increasing, and this increasing demand puts a lot of pressure on the conventional energy sources, oil, gas and coal. These fossil fuel based energy sources are limited in quantity and also cause environmental pollution. Therefore, there is a need of alternative energy source which can provide us energy in a sustainable manner. According to the current rate of consumption of coal, oil and natural gas, they can last only for 205, 40 and 53 years respectively. So, not very long time before which the sources of coal, oil and natural gas will be finished. And this statistics has been given considering the present utilization rate, which is ever changing in an increasing side. So, we never know that probably in a less amount of time these resources will be decreased, right. So, what are the need for the sustainable sources? To explain that, we have given this table like how much the current reserves of the different fossil fuels, what is the current production rate and what is the availability of the non-obvious. You look at the oil, current reserves is 1047.7 billion barrels, current production rate is 26 billion barrels. In this rate it will run 40.2 years, not even 50 years from now. Natural gas 5501.5 trillion SCF, SCF is a unit for the natural gas volume measurement. Current production rate is 102.2. With this estimate it will run 53.8 years. What about coal? 984 billion tons of coal's reserves is there. Current production rate 4.8 billion tons, little bit safe, not much, 205 years the amount of the coals which last. But again I should emphasize the fact all the statistics has been calculated considering the present growth rate and present economic growth rate. Now, if the utilizations rate and the growth of the economy increase, so this number will also be changed. So, today like we are pretty much convinced that the time has come, we have to look for an alternative source of energy. The conventional source of energy like coal, oil and natural gas, which were the blood of our civilization, which was a lifeline of our day to day life, we depended on them on very much. We can't imagine a single moment of our life without them. But we have learned that first of all like their resources are limited. We have given a statistics how long they can run, and the most important thing is that burning the fossil fuels we are adding severe environmental hazards and a phenomena called the global warming or greenhouse effect. Because of that, not only the animal and the plant ecology is changing, also like the temperature of the earth is changing, our overall weather on the earth's surface is altering and it is adding a several health hazards. So, it is a high time now we have to think about some alternate or some renewable sources of the energy. Now, today whatever we discussed, there are a lot of nice references also if you wanted to do some additional study. For example, some of this we have listed here like a role of renewable energy sources in environmental protection, a review paper, then conventional and renewable energy scenario of India present and future, energy sources and India's security, energy resources Indian scenario, and then there is a textbook Solar Photovoltaics Fundamental Technology and Application by Chetan Singh Solanki. So, you can look all of these references for additional subject matter and you will get these things. Thank you very much for your attention.